Hello students. Okay, so in this problem, a parabola is given and a circle is given. So if you take a point P on the parabola, okay, in such a way that that point is at a minimum distance from the center of the circle, okay, and once you get that point P, what they are asking is you try to get a circle making that point P as the center and make sure that the circle passes through the center of the given circle. Okay, so we need to find the equation of this new circle. Okay, so I know there's too much of information, but let's draw a diagram to understand what is going on here. Okay, so we have our parabola here, and then this is the vertex of the parabola. The origin is the vertex, and to get the distance of the focus, we can get it from this given equation. But let's focus on the point P. Okay, so the given circle is here. Now, how did I draw this here? I think if you look at this equation, so you have x minus 0 whole square plus y minus of minus 6 whole square is equal to 1 square. So the radius of the circle is 1 unit, and the center coordinates are 0 comma minus 6, so that is why I've put it here. And then we need a point P on the parabola which is very close to the center of the circle. Okay, so maybe the point P is somewhere here, so we need to find that. Okay, so if I take the coordinates of this point as x comma y, okay, so we need to find x and y such a way that the distance CP is minimum. So let's take this distance as L. Okay, and we know the coordinates of the center. Okay, so the center has coordinates 0 comma minus 6. So let's write this distance now. Okay, so L is we can just use the distance formula. So square root of x minus 0 whole square, so that is x square, plus y minus minus 6, so that's y plus 6 whole square. Okay, so if L is minimum, L square will also be minimum. Okay, so what we can do is, instead of taking L square, maybe I'll try to take some other variable. Maybe I'm just calling this as, I think we can call it maybe M. Okay, so this is, if I square it, x square plus y square plus 12x plus 36. Okay, so here the square of the distance is, I think we need to use a bit of calculus. Okay, so minima maxima here. So what we have here is, so this point satisfies this equation of the parabola. So I can substitute the value of y square, so that on the right hand side I just have only uh, one variable. Okay, so let's do that. So uh, let's substitute 8x here. So x square plus, okay, so okay, what did I say? I think if I substitute y square, yeah, I think that works, right? So y square is 8x. Why does it? Okay, so I think if you might have observed by now what mistake I have done. Okay, so now look at the stupid mistake. So where is this x coming from? That's really bad, right? So I don't know why I have written, instead of y I wrote x, and then I was getting really happy that I have a simple equation, but I am not. Okay, so let's change that. Okay, so after making that correction back to y, now we realize that substituting y square is not a good idea. Okay, so what is a good idea? I think from here we can get x as y square by 8, and then this is what we are supposed to substitute. Okay, I know that this becomes slightly complicated, but I think that's safe here. So x is y square by 8, so this becomes y to the power 4 by 64 plus y square plus 12y plus 36. Okay, so m is the square of the distance. So if I minimize the square of the distance between C and P, then I will be minimizing the expression that I have on the right hand side, right? So let us use a bit of calculus here. And then after that, we want, once we get the value of P, okay guys, so let's pretend that I have drawn a circle here. Okay, so let's pretend that this is a circle. Okay, so this is the new circle that we are after. Okay, so once we find the location of P such a way that M is minimum, and then I think we can use again the equation of a circle formula to get the equation of this new circle. So first let us minimize the function that we have just obtained. Okay, so as a side note, what do we recall from, let's say, maxima, minima from your calculus days? So if you have, let's say here we have a function of y, so the slope of the tangent line, okay, so at the minimum point should be 0. Okay, so the slope of the tangent line is the derivative, first order derivative, that should be 0. Okay, so if I get the slope and then equate it to 0, I'll get a few values for y, and one of those values should correspond to the minimum. Okay, so provided the second order derivative here, so dm by dy square, this has to be greater than 0. Okay, so this is the check. Okay, so for minimum, okay, so this is a check for minimum. Okay, so yeah, I'm assuming that we, let's say, know these things. Okay, so or I highly recommend that you go through this area from any textbook and then try and understand this. Okay, so now let's get dm by dy. Okay, so dm by dy. Okay, so this is 1 by 64, and then I have 4y cube. Okay, so then the derivative of y square is 2y, so y is just 1, so 12, and this is a constant, so we can ignore this. Okay, now we want this to be 0, right? So dm by dy is 0. So if this is 0, what do we have? We have y cube by 16 plus 2y plus 12 is 0. Okay, so here we have a cubic equation. So since we have a cubic equation, I think we will have to kind of guess what answers really work. Okay, so can we actually guess any value? By looking at this 16, maybe can I really get some nice value for y so that the left hand side amounts to 0. So and then the last two terms are, let's say, this is a plus 12. Okay, so that means I have to make the first two terms negative. Okay, so let's say I'm going for a value y equal to minus 4. So suppose if I take y equal to minus 4, we can see that uh, this becomes, let's say, minus 4 whole cube by 16 plus 2 into minus 4 plus 12. But then you can see that this is okay. Let me not write it this way. Okay, so I don't know why I did that, but yeah. Okay, so this is minus 64, so I have minus 4 and then minus 8 plus 12 Okay, so we are lucky here, right? So by taking y equal to -4, we see that the left hand side amounts to 0. Okay, so y is equal to -4 is one value, but we don't know whether that actually corresponds to a minimum point. But we cannot be happy here. We will have to find the other values of y. So take this expression and then maybe if let's write it little differently now. Okay, so if y equal to -4 satisfy, or let's say makes this expression 0. Okay, so makes y cube by 64 plus 2y plus 12 0. Okay, so makes this 0. So that means clearly y plus 4 is a factor of this, right? It divides. So we can use that, I think the synthetic division or something like that. So try and get the other factors. Okay, so I'm just writing this here, y cube by 64 plus 2y plus 12. Okay, so what do we have here? I think I can write y square by 64. So I'll have y cube by 64, and then if I multiply by 2y, so I'll get oh sorry, I need to multiply by 4. So 4 into this will be y square by 16. Okay, so I think these will disappear, so I have minus y square by 16. I think you try to bring the other terms, right? So 2y, and then I have y into y by 16. So we have minus y square by 16. Again, you multiply with 4 minus y by 16. So we will get minus y by 4. Okay, so what do we have? This gets cancelled. Okay, so this becomes plus plus. I'm sure you are familiar with these things. So 2y minus, or I think this becomes plus. So we have 9 y by 4. Okay, and then I bring that okay, so 12 here. Okay, so what do we have here? I think I might have done a mistake here. Oh, I made a transfer mistake. So look at this. I have y cube by 16, and then I took it as y cube by 64, and then that is why I was getting confused towards the end. Okay, so I'm so sorry. So let me change this and then let's redo it again here. Okay, that was supposed to be 16. Yeah, so when I move from board to board, this transfer mistakes do happen. Okay, so now let us do this synthetic division. I think it is fun doing this way. So what should I multiply with y to get y cube by 16? I will multiply y square by 16. So I have y cube by 16, and then take this 4 and then multiply with this y square by 16. So we get y square by 4, and then you subtract these terms. So this disappears, and then we have minus y square by 4. I think you borrow the next term, which is plus 2y. And then again, how do I get minus y square by 4? I need to multiply y with y by 4. So I have minus y square by 4, and if 4 multiplies this minus y by 4, I'll get minus y. Again, you need to subtract, so this becomes plus plus. So this is 3y, and then you borrow the remaining term plus 12, and then we have plus 3, I think we'll get 3y, I think plus 12. Yeah, now we are okay. So I think once you subtract, you get a remainder 0. That is what we want. So the other factor, okay, so y plus 4 is one factor of this expression. So the other factor is this. Okay, now let's say, what are we really aiming at? This dm by dy is actually this y cube by 16 plus 2y plus 12, which we want it to be 0. Okay, so in that process we have one factor. We identified one factor by guessing y plus 4, the other factor by this synthetic division, so which is y square by 16 minus y by 4 plus 3. I mean, I could have written without the fractions. I will leave that as an exercise to you. Okay, so now this is 0. Okay, we know y equal to minus 4 is one point where there is a possibility that the value of m is minimum. But now let's see if we have other points. Okay, so let's take the second factor and then equate it to 0. So before that, I'll try to let's say multiply everywhere in the numerator by 16. So if I do that, I get y square minus 4y plus 48 as 0. Okay, so let's I think, can we do this? So okay, so how do we factorize this? Actually factorize this, so it okay. I think we cannot factorize. So let's see the determinant. So how is the determinant looking like here? So b square minus 4ac. I think it looks bad here. Okay, so b square is 16 minus 4 into 48. Yes, this is really bad. So that is less than 0. So we don't have a real number here. Anyway, I mean, the roots of this quadratic equation are not real. So that means we are stuck with only one value, y equal to minus 4. But okay, does it really correspond to minimum? Let us check by getting the second order derivative. Okay, so I need to take a derivative of this once more. Okay, so I have d2m by dy square is 3 y cube ka derivative is 3y square, and then I have 16 plus 2, and the derivative constant is 0. Now here clearly, I mean, I don't have to substitute. Okay, so if I substitute minus 4, this is clearly greater than 0. So that means this point y is equal to minus 4 corresponds to a minimum value of m. Okay, so because it corresponds to a minimum value of m, okay, what can we do? We can use this to get the value of x, and then hence the coordinates of point p. Okay, so let's go back to our thing. So what do we have here? So we have here y is, okay, so let me use a different color. So y is minus 4. Okay, so if I substitute here, okay, so what do I get? So that is 16 is 8x. So that means x is 2. Okay, so the coordinates of the point P are x is equal to 2 and then y is equal to minus 4. So once we know the coordinates of P, okay, all we have to do is get the radius PC. Okay, so then I think we can use this data to get the equation of that blue circle. Okay, so I have put the coordinates here, and then let's get the radius first. Okay, so use the distance formula to get the radius. So just square root of, okay, so the distance, the difference of x coordinates 2 minus 0 whole square plus, okay, so minus 4 minus 6, so that is plus 6 whole square. So what is the radius here? I think this is 2 square 4 plus another 4, 8. So we end up having 2 root 2. Okay, now what if you know the center as h comma k and radius as r, we know the equation of a circle, which is x minus h whole square plus y minus k whole square is r square. Okay, so now let's just substitute here. So x minus 2 whole square plus y minus minus, so that becomes plus 4 whole square is 2 root 2 whole square. Okay, so let's see if it matches with any of the equations we have it here. Okay, I think we need to open it up a little. Okay, so let's open it up a little. So I have x square, and then from the second term, let's open this up. Okay, x square minus 4x plus 4 plus y square minus 8x plus 16. On the right hand side, we have 8. Okay, so what is this? X square plus y square minus 4x minus 8x, and then we have, okay, if this 8 comes to the left hand side, 8, and then we have plus 12 is 0. So I think it matches with, yeah, it matches with option A. Okay, so the answer is A.